Hey guys, this is just another take on the last video and just a couple of things that I might have left out. I just wanted to draw your attention to the data sheet over here and just let's have a look at it a little bit closer. Up the top of your data sheet, we've been using this formula a fair bit, this N equals mass on molar mass, number of moles equals mass on molar mass. But now that we're dealing with solutions, we can also look at this equation here, which is C equals N on V. And let's just look at how we can use this in a couple of ways. So what they give you is C, concentration, equals N, number of moles, on volume. Okay, so it's really important that we know what each of these things stands for. So this is our number of moles. Okay, obviously the units for this is moles. This is our volume. This is our always in liters, and this is our concentration. Okay, and this concentration here is specifically in moles per liter. Really important. Now, if we have a look at the maths of all of this, if you divide moles by liters, you get moles per liter. It makes sense. Let's have a look at manipulating these things. So, just like you have number of moles equals mass on molar mass over here, let's rearrange this. So let's rearrange it for N. N, if we multiply both sides by V, is equal to CV. Let's have a look at the units again. I'm going to write them underneath. If we have moles per liter multiplied by liters, well, inverse liters and liters cancel out, and you end up with moles. It makes sense, okay? So these things are equivalent. You can use these to solve a variety of problems. Normally, if we're dealing with solutions, we're talking about this. But if we're talking about masses dissolved in solutions, we're using this. You can use both of them. So let's just have a look at a quick problem to do with this. And I know I did this in the last video. Let's solve this one right here. Calculate the concentration in moles per liter of a solution that contains 16.8 milligrams of silver nitrate dissolved in 150 mils of solution. Okay, well, we know that our concentration here is equal to the number of moles divided by the volume. Okay, so what we need to work out first is the number of moles that we have, and then we can divide that by the volume. So let's calculate the number of moles first. Okay, the number of moles in this case, we're given a mass, so I'm going to use our formula to calculate the number of moles from a mass, which is number of moles equals mass on molar mass. Okay, that mass that we have is 16.8 milligrams. Now, 16.8 milli means times 10 to the minus 3. It means a thousandth of. So we can actually write that in as 16.8 times 10 to the minus 3 grams, which is milligrams. Okay, and our molar mass of silver nitrate, we're going to have to calculate that from our data sheet. So I'm just going to go to the periodic table, which is down the bottom. Now silver's 1 plus, and it goes with 1 nitrate. So there's silver there, it's 107.9. Okay, nitrogen is 14.01, so this is our silver, it's our nitrogen, plus 3 oxygens. So 3 times 16.00, and this is in grams per mole. Okay, and this is our O3, AgNO3 being silver. I'm just going to calculate that really quickly. 16.8 times 10 to the minus 3, divided by 107.9 plus 14.01 plus 3 16ths. And the answer I get is 0.0000409887587, and grams down here cancel, and you end up with moles because you divide by inverse moles. Okay, you can also write this quite neatly as 9 point, actually, let's leave that out of this for now. It might make things a little bit easier. All right, just drawing a little margin so we can continue working down the right-hand side. That's how many moles we have. So now if we go to this formula here and we say, well, the concentration, we know the number of moles, and we know the volume if we go back to the question as well. So the volume from the question is 150 mils. Now we're going to make sure that that's in liters. Otherwise, we're not going to get moles per liter. We'll get moles per milliliter if we put that in. So let's do that. Concentration equals number of moles divided by volume. Okay, our number of moles is 0.00009887587. moles. The number of liters we have now, 150 mils is 0.150 liters. So I'm just going to leave my calculator exactly how it was, and I'm just going to say divide that now by 0.15. Okay, and there's my answer there. So I get 0.00065911725 moles per liter. Okay, now if I go back to the question, I have a look. I was given 3 significant figures here and 3 significant figures here. Okay, so that means that I can give my answer and 4 from the periodic table to 3 significant figures. So 6.59 is 3 significant figures, rounding down because that's the 1 is the next number, times 10 to the minus 1, 2, 3, 4, times 10 to the minus 4 moles per liter is the concentration of that solution. So there's the final working.